Alright, so now today we'll be talking about areas of circles and sectors. Okay. Alright, so just talking about some stuff right here. We know that the radius goes out from the center of the circle to the edge. Now to find the area of the circle, pretty simple. It's going to be pi times the radius squared. Okay, pretty simple. Pretty straightforward. Now, what that does is that actually leads me into finding the circle sector. Okay, so if I wanted to find the area of this shape in here, this part right in here, okay, I could actually apply what I've learned last time, which was that you take the percentage of the circle. So you take the central angle and then you divide it by 360 degrees. Okay. And then what you're going to do is you're going to times that by the whole percentage. Now we're not going to multiply by 2 pi r like last time, but we will actually just multiply by pi r squared. Okay. Alright, now let's start giving some numbers to this. Let's say that this was 5 miles. There we go. No, let's go kilometers. Okay, so let's say that that was 5 kilometers, and let's say that this central angle was 80. Yeah, let's go 80. Let's keep it unpredictable. Let's not go some nice numbers like the book. Okay, so the area is going to be pretty simple. Okay, it's going to be pi times 5 squared, which is going to be 25 pi. Let's go kilometers squared. Not let's go, that's actually what the units are. Okay, now when I'm going for the area of the actual sector, okay, it's going to be 80 or 8 divided by 36 if you just reduce the two 2's or the 2 zeros. And then you just replace this with 25 pi kilometers squared. Okay. Then we multiply across the top, and 25 times 8 is definitely going to be 200 divided by 36 pi kilometers squared. And then we can just reduce that to, I believe that would just reduce to 50 over 9. 50 over 9. And you could even put the pi up top if you want, 225 or 227 divided by 9 kilometers squared. Okay, so that's how to find the area of a circle and its sector. Now we're going to talk about the segment. Alright, so now we're going to talk about the segment of circle and how to actually find the area of that. Okay, so what you have to do is take a look at 3 diagrams of what the segment of a circle is. Okay, so I'm going to draw out a couple, and then let me pause it so I can finish drawing it out. Alright, so let's start taking a look at some parts here. Okay, now if I take a look at this, and I'm going to draw out these 2 parts here. Okay, if I take the area of a circle sector, area of circle sector, okay, and that, if you remember, circle sector, what am I saying if you remember? That was like 2 minutes ago. Okay, if you take this area and then subtract this area of this triangle, so we're going to minus the area of the triangle, which is a shape we know how to get these two. Okay, we will actually get the area of a circle segment. Okay, so in other words, if I take this area, if I take this triangle away from this one right here, I'm left with this part out here. It's not going to look as well as with what I have, but you know, it still works nonetheless. Let's get rid of that. So this whole part right here. There we go. Okay, that at least looks somewhat better. Okay, so what we would do is find the area of the circle segment first, Alright, then find the area of the triangle, and amazingly enough, the triangle, the two sides are definitely going to be the radiuses. So we're dealing with an isosceles triangle, so that's kind of cool. The central angle is going to be the vertex angle, and the two base angles are going to be that. So we can actually use some trig right here to actually figure this out. And then once we subtract those two, we'll be actually able to find the area of the circle segment. Okay. Alright, so let's start saying that this is 120 degrees. Okay, so if that's 120 degrees right there, and let's say that this was 13 inches, okay, the actual radius, what I would do is find the area of the circle sector first. Okay, so first off, that would be 1/3, because 120 is 1/3 of that, times the area of the circle sector, which would be 169 pi. Okay, and 1/3 of that. And that would be about 56.3 pi units, okay, or pi inches squared. Jeez Louise, inches squared. Okay, now to find the area of the triangle, I'd probably treat it like a plain old isosceles. Now what I would do is draw it down the middle. Now if that's 120 degrees, that makes it 60 and 60. Okay, that would make these 90 degrees. Oh, that's very nice. Okay. Right, so that's 60 and 60, so that makes these 30, so it's a 30, 60, 90 triangle, so I don't even need to use trig for this. I can actually just go ahead and use special right triangles. Okay, so if this is 13, that is twice the actual short leg. Okay, so that's going to be the height of the triangle, so it's going to be 0.5 times 6.5, which is the height, which is half of 13, and then I'm going to times that by the actual entire base. Now this part is just going to be 6.5 square root of 3, so this is going to be 13 square root 3. So it's 13 square root of 3. Okay, now if you notice, I've got a lot of unsavory numbers right there, so I'm going to go 0.5 times 6.5 times 13, and this is going to be 42.25 root 3 units. Okay, now to get this to be exact, I'd probably make this 56 and 1/3. You could represent it like that. Okay, alright, now if you notice, these do not in any way, shape, or form actually have it. So this actual area of this circle segment is actually going to be this long number, 56 and 1/3, so 0.333, repeating. Okay, pi inches squared minus 42.25 root 3 inches squared. And the cool thing is that I don't need to break that down any further because I can't. Now if you did want to, you would not get as exact a number as what I just did. But the cool thing is that you can actually find the circle of the segment area by just actually working your way down like this. Okay? Alright, that's it for working with actual segments of circles and areas of circles. I will talk to you later. Bye.